Okay, this is the worksheet solving spheres. At the top, they give you the formula for surface area and volume of the sphere. The S is the surface area, and the V is the volume. And right here, they're just asking you to plug those values in. So I've got a basketball with a radius of 6 inches. So they just plugged the 6 in for the radius, and that's where they got the 452.4. So you can do these in your calculator. So I'm just going to plug in, I'm going to go ahead and plug them both in at the same time, since I'm looking for both values. So I'm going to plug in 4 pi, instead of r, I'll be using an x squared. So that's my surface area formula. And then my volume formula is going to be 4/3. Oop, I need to do that. 4/3 pi, and then r. So I'll be using an x again, and then cubed. So I have to use my exponent key and put the cubed in. So I've got both my formulas in here. Now, I've put in a fraction right here, which means that my table's going to generate fractions as answers, and they've already given me decimals. Oh, maybe it won't because of pi. But I could go to mode and arrow to the second page and change it so that it's automatically going to give me, and I actually was already in decimals. So now I'm going to go to my table setting, and I'm going to change it from auto to ask so that I can specifically give the values that I want. So my first one was the basketball, and that's where the 452.39, and they rounded to 452.4, and the volume is 904.8. And volume, remember, is cubic, so this would be inches cubed. Now for the next thing, I have a baseball with a 9.2 centimeters, so I'm going to put in 9.2. And I get back, so again, we were plugging in 4 pi times 9.2 squared. You don't have to write that part though. Just so you're aware of what's going on. This is inches squared. And the formula next to it is volume. And then the last one is a cantaloupe of 7.5. And it gives me approximately 706.9 inches squared and 1767.1 inches cubed. So those are the values that I got for my surface area and volume of these particular shapes. Now, if you read part 2, it says this function, v of s, equals 0.094s to the 3/2 power, could be used to approximate the volume of the sphere in terms of its surface area. So if I've been given the surface area, instead of backing up and finding the radius and then going forward to find the volume, this formula would take me straight from surface area to volume. So we're not going to do this part. We did it in class, but for the purposes of those of you that missed class, we're not going to go through that. For this, they've given me v of s equals v of 452.4 because we're doing the basketball. So they went back up here and they got the surface area of the basketball, 452.4, and we want to plug that in and see if we do in fact get the same answer. So I'm going to go to my main screen on my calculator and just plug this into my calculator and see if I get that. 0.094, 452.4 raised to, and I'm going to use my fraction bar, the 3/2 power. And I got 904.5. So it's a little bit, it's just a little bit off on the decimal point. And that's because we're rounding. Whenever you round, and the more decimals that you use in an equation and the more rounding that occurs, the more off you'll get each time. So for the next one, the cantaloupe, I'm going to use the surface area of the cantaloupe that we found, which we found to be 706.9. And I'm going to plug it in to the formula. So I'm going to plug that into my calculator. 0.094 times 706.9 raised to the 3/2 power. And I got 1766.71, which is pretty close. Pretty close to what we got up on the top. All right, so now it says, suppose that a spherical balloon has a surface area of 325 centimeters when it's deflated. Use this formula to determine how many cubic centimeters of air it would take this balloon to fill without stretching the surface. So this is our surface area, and we're going to be plugging it into this formula. So V of 325 and I'll plug that in my calculator. So I plug in 0.094 times 325 raised to the 3/2 power, and I get 550.75. This is volume, so this is cubic inches. Now, for the next problem, it says more and more air can be pushed into this balloon until it reaches the maximum volume of 2,000 cubic centimeters. Use this formula to figure out how much the surface area has been stretched. So this time they're giving me volume, and I'm working this problem backwards. So I have the volume. I have this piece. And I'm going to plug into my formula and work this problem out backwards. So let's see. I have 2,000 cubic centimeters, and that equals 0.094 s to the 3/2 power. Well, I need to isolate that variable first, so I'm going to divide both sides by 0.094. That gives me a rather large number, 21,276.6 equals s to the 3/2 power. Now, looking at this, I need to get s by itself, and I have currently s to the 3/2 power. I need s alone, or I really need s to the first power. So I need this 3/2 to become 1. Now, in order to do that, I need to multiply by the reciprocal. So I need to multiply my exponent here by the reciprocal, or 2/3. So I'm going to raise this to the 2/3 power. If I raise one side of an equation to the 2/3 power, I also have to raise the other side to the 2/3 power. Now my point in doing that is to make these become 1. The 2's become 1, the 3's become 1. So I now have s to the first power. And over here, I'm going to put this value in my calculator. And I actually already have it because I did the division just a minute ago. So I'm going to go up and grab that value, and I'm going to raise it to the 2/3 power. And I get 767.8. And this is square inches. Okay, moving on to the back. We're just going to go through exactly what we just did, step by step. First thing we did was isolate the variable and the exponent. So we got s by itself. We did that by dividing by 0.094. And that's where that big number, 21,27,6.5 came from. After that, we're going to raise both sides to the reciprocal power. So we're raising both sides. In this case, the reciprocal would be the 2/3 power. So I did the 21,27,6.5 raised to the 2/3 power. That gave me s to the first, which was 767.8. So now these are the steps that you follow in order to solve an equation that happens to have a fractional exponent attached to the variable. So let's look at A. We need to first isolate my variable with its fractional exponent. I'm going to subtract 11 from both sides. So I have a to the 1/3 equals 5. And I'm going to, now I need to get rid of that 1/3. So I'm going to raise this to the reciprocal power, or the 3 times 1 power. So it's 5 to the 3rd. And you get a equals 125. And you can find that balloon and scratch it out because you're not going to use it again. On B, my first move is to add 185 because I need to isolate the variable. So I have b to the 5th equals 244. Now I have to raise this, in order to get rid of the 5th, yes, of course you could take the 5th root, but this is a good example of why you might do these. It's a little faster for me to type in. The reciprocal is the 1/5 power, so I can raise this 244. I can just raise that to the 1/5 power, and that's actually a little easier on my calculator. You know what, I just realized that I just did that with 185. Should be 184, sorry about that. I was wondering why I kept getting the wrong answer. All right, on C, I need to isolate the variable with its exponent. And I've got two things I need to get rid of here. The 11 is the easiest thing to get rid of first. Multiply both sides by 11. And I have c cubed plus 4 equals 220. Now subtract the 4. So I have c cubed equals 216, which then you raise to the 1/3 power. And so I get c is 6. I think they're pretty self-explanatory. I guess let me jump down and let's do h. Let me rewrite it since the ink is coming through on the other page. I have 1/8 h to the 2.4 power minus 112 equals 400. Now there's two ways that you could think of doing this. I could go ahead and put 2.4 in my calculator and figure out what that is as a fraction, or I could think of this as 2.4 over 1. Either way, I need to isolate the h. So my first move is going to be to add 112 to both sides. So I have 1/8 h to the 2/4 power equals 512. Now I need to clear this fraction or get rid of that 8. Remember, 1/8 is the same thing as dividing by 8. So to get rid of it, you multiply by 8. So that gives me a pretty big number over on the right-hand side, but never fear. It'll go away here in just a second. And now I'm going to raise both of these to the reciprocal power. So I'm going to raise it to the 1/2.4 power. So in my calculator, I've got the 4096, and I'm just going to raise that to the 1/2.4, and I get 32. And that's it. That's pretty much how you get rid of one of those fractional exponents, by multiplying by the reciprocal power.